Here's another video for my GCSE students revising logic gates. This time around we're going to do the NAND gate. It looks very similar to an AND gate, but not quite. So let's have two inputs, A and B. And so that is an AND, but we're going to put that circle on and then have the output Q. Now if you think back to, let me just grab some paperwork, here we go. If you think back to the NOT gate, the circle told us that there was going to be an inversion, and the AND gate looked like that. So now it's an AND gate, but then we're going to have a NOT. So actually this is functionally equivalent to A and B, and then drive the output of the AND gate and then go through a NOT. So that would be A and B at that point, and then we're going to NOT it, so it's A and B knotted, going to output Q. Okay, so if we were to draw or complete a truth table for this, let's do it. So B, A, Q, 0, 0, 0, 1, 1, 0, 1, 1 are the possible inputs. And then so the outputs are going to be thus. So if you think about it, well, think about what the AND gate was. Well, the AND gate will output true if both the inputs are true, and then otherwise it's going to be false. Well, we're going to flip that around. So we're going to have this situation. So let's just think about that for the moment. If you did 0 and 0, the output would be 0 if you were to use an AND gate, but then you're going to go through the NOT, so then that's going to make that 1. If you were to do 0 and 1, the output would be 0 at that point, but then we're going to go through the NOT, so the output will be 1. Same again there. But then if we did 1 and 1, well, 1 and 1 is logic 1 or logic true, and then we're going to go through the NOT gate, so not true is false or 0. If you prefer, what we could do, we could just write that out in another way just to add some clarity to it. So this time around we'll have 0, 0, 0, 1, 1, 0, 1, 1, and this time we'll have B and A. So 0, 0, 0, 1, so that's the logical AND, and then this time we'll have this column here, B and A, negated like that, so 1, 1, 1, 0. So hopefully you can now see where I got this 1, 1, 1, 0. The logic AND operator, if you want to write this out algebraically, you could, if you wanted. I don't recommend it, but you could write Q equals not A and B, but we don't do it like that. So what we would do, we would just say Q equals A and B knotted, and the way we would actually read that, we would say Q equals A NAND. You read those two signs in one thing, so Q equals A NAND B, like that. Okay, so that is this bit here. That's your common notation for a NAND gate. Okay, hopefully that's useful, a useful reminder for you.